Hello students, I am Nilanjana Sanyal. Welcome you all to my channel Learners Online Math Classes. Our today's topic is multiplying logarithmic terms with different bases, and we cannot use a calculator to get the products. Okay? So we will be solving two questions in our today's session, and the first question will be solved using two different methods. Therefore, without any further delay, let us start with our today's session. First of all, let us look at the given question, the first question of this session. Find the value of log of 125 to the base 9 times log of 3 to the base 25. We are having two logarithmic terms to be multiplied together, but we may have multiple logarithmic terms as well. And the bases are different obviously. One is 9, the other is 25. We have to get them to the same base. Either we may make the same base as 9, or we may make the same base as 25, or we may make the same base as some other number. We will be solving this question 1 in two methods, using two methods. In the first method, I have converted both the terms to base 10. And in the second method, I had made the common base as base 9. So I had to keep the first term as it is because it is in base 9, and I had changed the second term. You can take the common base as 25, you can take the common base as any other number, and you will be seeing you are always coming up with the same product. But you have to choose the base carefully so that you cannot use the calculator. This you have to keep in mind. You can take any number as the base, but you have to know the values of those logarithms without the calculator. Okay, this is important. So first of all, let us take the common base as 10. So this is equal to log of 125 over log of 9, and this will be equal to log of 3 over log of 25. And this 125 is over here and 25 is over here. So 125 is 5 to the power of 3 and this is 5 to the power of 2. We have to get something so that we can cancel or we can get the values, because we are not allowed to use the calculator. So how do we find the value? And this 9 is 3 to the power of 2. So we write them in this form. Log of 5 to the power of 3 over log of 3 to the power of 2 times log of 3 over log of 5 to the power of 2. And usually what do? We take the coefficient and put them in the power place. Write them as the power of the arguments. But this time we will be doing just the opposite. We will be taking the powers and writing them as coefficients. So this will be 3 times log of 5 over 2 times log of 3 times log of 3 over 2 times log of 5. And now this log of 5 in the numerator and this log of 5 in the denominator will be getting cancelled, and this log of 3 and this log of 3 will also get cancelled. Because we have to come to a numerical value, numerical product. We do not know what is the value of log of 5, or we do not know what is the value of log of 3, and we are not allowed to use a calculator. That is why I am saying that you can take any number as the common base, but you have to be sure that you know the values of those logarithms. Okay? So we do the cancellations, and it is 3 over 2 times 2 is 4. So the answer is 3 over 4. This is the first way where the common base is taken to be 10. Now let us take the common base as 9. You can of course take the common base as 25 as well. It is, I am giving you, this is a question that I am giving you as homework. You may take it as a homework question. Change the base to 25 and see what happens. Can you get to some numerical value as your product? Check. Okay. Now since we are changing the base to 9 for this term, it is log of 3 to the base 9 over log of 25 to the base 9. And this is of course 5 to the power of 3 and this is 5 to the power of 2. And over here, since the base is 9, we do not know what is the value of log of 3 to the base 9. So therefore, if we get a 9 over here, we know log of 9 to the base 9 is 1. Therefore, I have written 3 as 3 is square root of 9 or 9 to the power of half. And actually I thought that I'm not having much space remaining, so I have written in place of half, I have written 0.5. Okay, because you need some more space to write a fraction. So that is why I have written, instead of 9 to the power of half, I have written 9 to the power of 0.5. And of course you know 0.5 is equal to half. Okay. And now, as we have done before, we will be bringing the powers and writing them, bringing down the powers and writing them as coefficients. So it will be 3 times log of 5 to the base 9 times 0.5 times log of 9 to the base 9 over 2 times log of 5 to the base 9. Okay. And now this log of 5 to the base 9 and log of 5 to the base 9, these two will get cancelled. And log of 9 to the base 9 is of course equal to 1. So it is 0.5 times 1 is 0.5, or half times 1 is equal to half. So it is 3 times half over 2. Half divided by 2 is equal to 1 over 4. So 3 times 1 over 4 is 3 over 4. The same value. You see, if you take the common base as 25, even then you will be getting the same answer, that is 3 over 4. Okay. Coming to the second question of our today's session, it is find the value of log of 100 to the base 2 times log of 2 to the base 100. The base and argument, they have got flipped. What will be the answer? Should we be taking the common base as 2 or common base as 100? If we take the common base as 100, then we have to change this term. It will be log of 100 to the base 100, that is fine, over log of 2 to the base 100. But do we know what is the value of log of 2 to the base 100 without a calculator? Check if you can find the value. I have taken the common base as 10. Okay. So we write log of 100 to the base 2 as log of 100 over log of 2 times log of 2 over log of 100. And this log of 100, this log of 100, they will be cancelling each other. And this log of 2 and this log of 2 will be cancelling each other. Okay. So the answer is equal to 1. Now this gives us another important property of logarithms. That is, log of b to the base a times log of a to the base b is always equal to 1. When the base and the arguments, they are getting flipped and those two terms, logarithmic terms, are getting multiplied, the product has to be equal to 1. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.